Yes. Hello dear students. So today we are going to discuss about one chapter. So that is important chapter in physical chemistry, thermodynamics. Right. So all of you know thermo means heat, dynamics means motion, right? So what is meant by thermo means? Thermo means heat, dynamics means motion, right? So heat motion from one place to another place, or one system to another system, or one body to another body. So that means the flow of heat. Entire thermodynamics is going to express about flow of heat. How the flow of heat will be changes from one system to another system, or one reactants to products, or chemical reaction, or systems conversions, or anything. How the heat energy will be exchanged, right? So somehow important things are there. We have to understand the importance of thermodynamics. It is one of the big branch of physical chemistry, and it is particularly applicable for macro particles, means big particles only, right? Okay. Then the importance of thermodynamics, right? It gives the relation between heat energy and other form of energies. Right. So what is the heat energy and what is the other form of energies? Heat energy will be denoted with Q. Some terminology symbols will be there in thermodynamics. We are able to know all those things, right? So other form of energies may be work is the other form of energy, internal energy is the other form of energy, entropy, enthalpy, Gibbs free energy, Helmholtz energy function. These all are other form of energies. Once heat is observed by the system, or so anything happened by exchanging of heat energy, so how that energy will be converted into other form? According to first law of thermodynamics, or law of conservation of mass, that explains that energy cannot be created, cannot be destroyed, but it can changes from one form to another form. Energy ni create చేయలేము లేదా డిస్ట్రాయ్ చేయలేము. సో ఏం చేయొచ్చు, వన్ ఫార్మ్ ఆఫ్ ఎనర్జీ, ఒక ఫామ్లో ఉన్న ఎనర్జీని ఇంకొక ఫామ్లో ఉన్న ఎనర్జీకి కన్వర్ట్ చేయొచ్చు, రైట్? సో మీన్స్ వీఆర్ గోయింగ్ టు డిస్కస్ అబౌట్ మోషన్ ఆఫ్ హీట్, మీన్స్ ఫ్లో ఆఫ్ హీట్. సో that heat energy will be how it will be converted to other form of energies. So that going to explain with the help of thermodynamics, right? Then so there is that energy, whatever is the energy, how this energy is accompanying in various physical and chemical processes. How the energy will be accompanying physical and as well as chemical processes. Physical and chemical processes. The energy accompanying means how the physical process will be carried out, what will be the change of energy. Chemical process is carried out, what will be the change of energy. How the energy is accompanying during a physical process and during a chemical process. So we know that physical process, what are meant by physical processes? Physical processes, right? So physical processes means, so we have to know aware about physical states. How many physical states are there? Matter will be existing in 3 states. One is solid state, liquid state, and gaseous states, right? So there is a transformation of one phase to another phase, that means, or one state to another state. So that is the process is involved physically. So during that physical process, if anything, right, so one process we are going to discuss, that becomes solid is converted to liquid. Solid is converted to liquid, or else one more process is there, liquid is converted to gas, or we may call as vapors. Solid substances becomes converted to liquids, or liquid substances becomes converted to gases or vapors. When the solid is converted to liquid, means by providing heat only, these left hand side solid and liquid will be absorbing some amount of heat energy, then that will be converted to right side, means heat is observed. In this case, heat is observed. Heat is observed. When heat is observed, such process we may call as endothermic process. Endothermic process. Whatever is the reaction or process is carried out, these are the physical processes, right? So physical means, so the physical state will be going to change with the help of heat energy. Whenever solid is absorbing heat energy, that is converted to liquid. Liquid is absorbing heat energy, that is converted to gas or vapors. So hence in this process heat is observed, therefore hence the process becomes was endothermic process, right? So the reverse means the liquids are converted to gases, right? Liquids are converted to gases, then gases are converted to liquids. So the second process will be there. So here the liquids are converted to solids, then gases are converted to liquids. When liquids are converted to solids means by decreasing the temperature. When temperature is decreasing means somehow energy will be released. During these processes, energy is heat energy, particularly energy in the form of what? Heat. Heat energy is released. Heat energy is released. Such process is known as exothermic process. Particularly the thermodynamics is going to explain how the physical processes are carried out, chemical processes are carried out, these processes how accompanying of energy changes. What is, we said that heat energy and other form of energy relations it will give. So before that how heat energy will be changes in physical processes, right? So then coming to the part of chemical processes. Chemical processes. Any chemical reaction we have to consider, right? So chemical processes means chemical reactions. Reactants are converted into products. So by loss of energy or by gaining of energy, that reactions will be carried out. So for example, right, so we may consider combustion process. That means what is meant by combustion, right? So that is carbon that combined with oxygen or reaction with oxygen produces carbon dioxide gas, right? So this oxygen is the gas and carbon will be in the form of graphite. The physical state of carbon will be graphite. So graphite gas will be converted to gas means during this some energy will be released. Delta H is negative, therefore this is the reaction is known as what? Exothermic reaction. The combustion is always exothermic reaction. Particularly physical states, physical processes and chemical processes. How the physical processes will be carried out, how the chemical processes are carried out, what is the energy change between the physical and chemical processes, that we are going to discuss with the help of thermodynamics, right? So it is very easy as you understand the concept clearly, right? So because the physical process we have to know idea, chemical process we have to know idea, right? So then energy accompanying or changes during physical and chemical processes, how it will be happen, all those things will be explained, right? So then one more, so whenever energy is changes from one form to another form, right? So therefore the efficiency of heat enzymes, right? Efficiency of heat enzymes. Efficiency of heat enzymes also can be explained with the help of thermodynamics, right? So that is Carnot cycle will be there, heat engine, any heat mission is there. So whenever the heat is transferred between the system and so otherwise surroundings, we use it to get the terminology also, right? So at the end, what is the efficiency of heat engine? For example, here we are going to say, so whenever we may purchase a motor vehicle, right? So during purchase only, so they may give the efficiency of heat engine. What is the engine lifetime? Efficiency is nothing but lifetime, right? So that, what is that efficiency? How much it will be converted one form of energy to the other form of energy? Almost vehicles around 15 years is the lifetime, means so that machine will be going to destroy after 15 years, right? By uses continuously, right? The efficiency will be up to a certain period only, right? So that is always less than 100% that we are going to prove, right, with the help of Carnot cycle, right? Then, so the main thing, so these are the two parameters we have to discuss in detail, right? So one is the what? Feasibility of the reaction. Feasibility of reaction. What is meant by feasibility means whether the reaction is taking place or not. Whatever is the reaction we may consider, that reaction is taking place or not. How we have to say the reaction is taking place or not means reactants are converted to products. If there is a conversion of reactants to products, yes, there is a reaction. If there is a reaction means feasibility of a reaction is there, right? So what is meant by feasibility means whether the reaction is taking place or not. That is going to explain, right? If the reaction is feasible, right? Whether the reaction is, it is a spontaneous reaction or not. Spontaneous reaction or not. Spontaneous or not. When the reaction is feasible. If the reaction is feasible means the reaction is taking place. How the reaction is taking place? So the reaction will be taking place. So from conversion of reactants to products, there is a reaction. Is that reaction becomes a spontaneous reaction or not? What is meant by spontaneous reaction means that reaction will be taking place continuously or not, right? So whenever we are doing work, we are doing continuously work or not, right? So that concept, these two parameters, feasibility and spontaneity, will be explained with the help of thermodynamics, right? So here we use it to tell some processes, spontaneous processes, right? So what are the spontaneous processes, right? So means always it will be taking place continuously, right? So the spontaneous processes means spontaneous processes. Right. So what are the spontaneous processes? These processes will be takes place without any external source, right? So that will be takes place without any external source. Without source, the process should be carried out, or with a small initiation. With a small initiation. Right. So two possibilities will be there. One is what? Without any external source, without using any source, the process should be carried out. Another one is with a small initiation. We have to initiate the process. After that, that becomes continuous process, right? Two possibilities will be there. So based on these two possibilities, so what are the spontaneous reactions? We'll see, right? So one is the flow of heat. Flow of heat. Right. So the flow of heat is a spontaneous process. The flow of heat will be takes place from high temperature to low temperature. Whenever temperature differences will be there, therefore the flow of heat will be takes place automatically from high temperature region to low temperature region. Here I am going to explain one example, right? Just simply take hot water in a beaker, or open beaker, or open bottle, or open vessel, anything, right? So just that hot water is kept it on the bench, and you may go for movie, right? After completion of movie, you can come back and see. What do you observe? Heat will be transferred. That hot water becomes cooled. Means that heat will be transferred from hot water condition to environment. Therefore, so that is always automatically takes place. How hot water we are getting means with the help of small initiation. By heating, we got hot water. So then after that, the process becomes continuous process, right? Therefore, that is flow of heat is from high temperature region to low temperature region, right? Next, flow of water. Flow of water. So we know flow of water. Water flow is always from high temperature, high altitude to low altitude, or high region to low region, right? So that means high hills to low hills. That is example of waterfall only. Simple, that is high altitude, high region to low region. High region to low region. Region is nothing but what? High altitude to low altitude, right? So that means next, flow of gas. Flow of gas. Gas will be flow from, that we may call as even expansion of gas, that is from high temperature region to high pressure region to low pressure region. Flow of gas will be takes place from high pressure region to low pressure region. These all the processes are naturally occurring processes. Naturally occurring processes. all the naturally occurring processes becomes what? Spontaneous process. All the naturally occurring process becomes spontaneous. With the help of our terminology, thermodynamic terminology, we use it to express about spontaneous process with the help of terminology. So we have to identify whether the process is spontaneous or not. ఏదైనా ప్రాసెస్ కంటిన్యూస్గా జరుగుతుందా లేదా. సో సమ్ పారామీటర్స్ ఆర్ దేర్ ఇన్ థర్మోడైనమిక్స్. వాటిని బేస్ చేసుకొని మనం ఈ ప్రాసెస్ కంటిన్యూస్గా జరుగుతుంది, ఇది జరగట్లేదు, నేను కంటిన్యూస్గా చదువుతున్నా ఎగ్జామ్ కోసం, దట్ ఈస్ స్పాంటినిటీ. సో లేదా ఏదో ఫంక్షన్ ఉంది, 4 రోజులు పోయిన ఏదో రీజన్ తోటి క్లాస్ అటెండ్ కాలే, రైట్, దీస్ ఆల్ ఆర్ నాన్ స్పాంటినియస్. వెన్ ఎవర్ యూ ఫాలో స్పాంటినిటీ, డెఫినెట్లీ యువర్ గోల్ విల్ బి అచీవ్, రైట్. సో in this entire period you have to maintain spontaneous. What is meant by spontaneous means thoroughly you have to regularly attend the class, regularly reading all those things, regularly you have to cover the entire syllabus and repeatedly you have to read. So that is the process is becomes spontaneous process, right. This all, and in addition to this one more process also will be explained with the help of thermodynamics, right. So that is the what? Attainment of equilibrium. What is meant by equilibrium? During the process is conversion, either it is a chemical process or a physical process. What is meant by equilibrium? The attainment of equilibrium also can be explained, right. So this is the things we are going to explain with the help of thermodynamics. We have to know, means in entire thermodynamics what we are going to discuss one by one, what we have given importance of thermodynamics, all we are going to explain with the help of utilization of various terminology. So in thermodynamics, right. So simple thing, thermodynamics ante em ledandi, heat energy అనేది ట్రాన్స్ఫర్ జరుగుతుంది. హీట్ ఎనర్జీ ట్రాన్స్ఫర్ వల్ల ఏమేం ప్రాసెసెస్ జరుగుతున్నాయి, ఏమేం చేంజెస్ జరుగుతున్నాయి, సో ఆ చేంజ్ దేనివల్ల జరుగుతుంది, ఆ చేంజ్ జరగడం వల్ల మనకు అవుట్పుట్ ఏమొస్తుంది, దట్ ఈస్ ద థింగ్, రైట్. సో ఎంటైర్ ద చేంజెస్, వాట్ ద చేంజెస్ ఆర్ మేడ్ ఇన్ దట్ reaction, so that will be explained with the help of heat only. So that is the called thermodynamics, right. And it has some limitations, right, it has some limitations, right. So these above all are importance of thermodynamics and these all are limitations, because directly mentioned thermodynamic parameters in our syllabus, but we have to know the importance. So then only what we are going to discuss in all classes about thermodynamics we able to know, right. So limitations means this is applicable for only applicable for macro particles. Macro particles means whatever is the macro systems are there, macro particles or macro systems are there, so these thermodynamics will be applicable for that, right. And there is no explanation of rate of reaction. So rate of reaction, what is meant by rate of reaction, that we will get in chemical kinetics, right. Chemical kinetics only going to explain about rate of reaction. So what is meant by rate of reaction, then it could not explain mechanism of the reaction, mechanism of reaction. So that is also we may call as path of reaction. What about the reaction pathway, where the temperature will be changes, right. So that pathway cannot be explained with the help of thermodynamics. These are the somehow limitations, right. So huge importance are there, right. So with the help of all those things we are going to discuss entire thermodynamics. So we know the importance of thermodynamics, right. So importance of thermodynamics, then limitations of thermodynamics. So we have to understand all these concepts. So we have to know some basic terminology which will be involved in thermodynamics. ఇప్పుడు ఏదైతే డిస్కస్ చేసినామో ఇదంతా మనం అర్థం చేసుకోవాలంటే దానికి కొన్ని పారామీటర్స్ అవసరం. ఆ పారామీటర్స్ని ఫస్ట్ అర్థం చేసుకుంటే మనం ఆ ప్రాసెస్లన్నీ ఈజీగా ఫైండ్ అవుట్ చేయొచ్చు, రైట్. సో సమ్ వేరియస్ థర్మోడైనమిక్ పారామీటర్స్ ఆర్ దేర్. సో వాట్ ఆర్ దోస్ థర్మోడైనమిక్ పారామీటర్స్, రైట్. సో దట్ విల్ బి సి, రైట్. సో దట్ ద ఫస్ట్ వన్ విల్ బి బేసిక్ టర్మినాలజీ. Basic terminology involved in thermodynamics, right. So 3 terms are there. So I am going to write first the terms. One is the system, the second one is the surroundings, Then third one is the boundary surface. Boundary surface. So we have to understand the things first this, right? So this, whatever is the thing, listen and you have to remember whatever the topic we are going to learn in this entire chapter, even further physical topics, you have to learn the topic or you have to remember the topic either with the help of diagram or with the help of equation. Both can help to remember the concept easily, right? So if you may go through the statements, so right, that cannot be rememberable for long period of time, then how will remember? So we have to get the picture out of all those things. With the help of that picture we will get some idea of that, right? So here we are going to discuss, right, so system, surroundings and boundary surface. For example, this entire board is, I am going to say, that is the universe. Entire board is universe. In that entire board, just I am going to select only some portion. This is the portion I have selected. Rest of the thing will be there, but my focus is, my observation is, my study is on this particular area only. Whatever is the specified portion which is under our observation, that is called system. That is called system, right? So then rest of the area of board is there, right? Except this, the remaining part of the area, that will be what? Surroundings. How many surroundings are there? So means entire part will be surroundings only. This is the surroundings. This is the surroundings, right? So except this area, the remaining part of this universe is called surroundings, right? Simply what we have to say, the system. System will be specified area, right? Specified area under our study. Specified area which is under our study, that is called system, right? Specified area means anything we have to consider, right? So today live example only we have to consider, right? So every person is know, today elections are going on, results announcement day in various states, right? Entire Indian people are going to see the results of always Tamil Nadu and Assam and Kerala, right? Puducherry and other state, right? So means all the people focus on that particular states, means that are called system. The remaining part of the India is called surroundings. So those 5 states and remaining states combined together, that will give India, that is called universe, right? So therefore simply think that observation, whatever the observation, for example our classroom is the system because my observation on this class. So the rest of the thing, remaining Hyderabad region is surroundings. My classroom and other Hyderabad both combined together, that is called universe, that is called Hyderabad, right? Or else India is the system, the other countries are the surroundings, the plus sum of India and other countries, that becomes universe, that is the globe, right? So therefore system plus surroundings, system plus surrounding is equals to universe. System plus surroundings is equals to universe, right? So this is about surroundings. Surroundings is what? Rest of the system, rest of the universe, or remaining part of the universe also we have to say, right? So remaining part of the universe except system. The remaining part of the universe except system is called surroundings. Now we are going to discuss about that third one. So this is the boundary surface, right? That is the word boundary surface. What is meant by boundary surface? The area which divides system and surroundings. This is the portion I have selected. How I have selected? With the help of area, right? So that area which divides system and surroundings, that is called boundary surface, right? So which divides system and surroundings. The area which divides system and surroundings is called boundary surface, right? Or else the area which divides system and surroundings, right? So that is the terminology. Simple, we have to understand. Whatever is under our observation, for example, you are going to see the nodes, right? Your nodes is the system. So the rest of the people and surrounding you are surroundings, right? So the benches are the area which divides you and others, that is called boundary surface. Boundary surface conditions also we have to know. So how many type of boundary surfaces are there, right? System means any specified area which is under our study or observation, that is called system. The remaining part of the universe except system is called surroundings. Then boundary surface means the area which divides system and surroundings is called boundary surface, and system plus surroundings is equals to universe. We have to understand anything we have to consider, that is the system, right? The remaining part is surroundings. Then sum of system and surroundings, that is called universe. So the area which divides system and surroundings, that is called boundary surface. How many types of boundary surfaces are there? So that is the important, right? So types of boundary surfaces we are going to discuss, right? Boundary surfaces. How many boundary surfaces are there, right? So one category I am going to get two type of boundary surfaces. One is what? Fixed boundary surface and movable. Fixed boundary surface and movable boundary surface, right? One is the fixed or movable, right? So means the boundary surface may be moves or that may be fixed, right? So this is the one kind of boundary surface, right? So the other kind of boundary surface will be, right? Other kind of boundary surface will be, right, fixed and movable, and it is imaginary or rigid. It is imaginary boundary surface or rigid. Imaginary means, for example, this classroom is there. So benches this side and this side is there. So just you have to imagine one curtain between these two benches. That is called boundary surface. That room, two rows will be, these two rows will be separated with a, just we have to imagine one curtain will be there, right? So curtain means that is we have to imagine, right? So that is the imaginary boundary surface. Or else we may put one right wall in between this, that is the wall is the fixed or rigid, right? So that rigid cannot be movable, but imaginary we have to move either this side or that side, that is depending on the various properties, right? Okay, so one is the what? One is the condition, that is what? Fixed or movable. The other category, second category of boundary surface is what? Imaginary boundary surface or rigid boundary surface. Then third category will be there, right? So that will be two times. One is adiabatic wall, then diathermic wall. So we have to understand all this terminology. If we understand this all terminology, it will be easy to understand further processes or topics, right? Adiabatic wall means whatever is the wall that will be present between the system and surroundings that cannot allow heat energy. That cannot allow heat energy. Whatever is the wall, we consider this is the system, this side is the surroundings. In between this, there is no exchange of heat energy. Such system is known as, such boundary surface is known as what? Adiabatic boundary surface or adiabatic wall. So right here we used to get the condition will be delta Q. Delta, what is meant by delta? We will discuss. Delta Q will be not equals to 0. Means there is no change. Both are having same heat energy. For adiabatic condition, delta Q will be 0. Right? Diathermic wall means whatever is the wall we have to imagine or you have to put between the system and surroundings that cannot allow the temperature. That cannot allow the temperature. That means the change of temperature will be 0. Delta T will be 0. These are the three categories of boundary surfaces will be there. We have to understand that because sometimes we have to imagine. See, all people we know the cylinder containing gas. How will be stored gases in the cylinder means with the help of pressure only. right, with the help of pressure. Right, so there we have to use one piston, that is the weightless frictionless piston in the cylinder. So with the help of pressures, the piston will move up or it will move down. So the various conditions we are getting, expansion of gases, compression of gases, all those things will be happen. So that piston will be imaginary. So right, imaginary, and that will be movable, or all those things, conditions we have to consider. How many type of boundary surfaces are there? 3 categories will be there. One is fixed boundary surface or movable boundary surface. This cannot be moved, this will be moved, right? Next one is rigid, means that is always stay there only. Imaginary means we have to imagine between the system and surroundings. Other two will be, so one can does not allow the heat energy, one can does not allow the temperature, right? So with respect to this, delta Q is equals 0, delta T is equals 0. These are the conditions are applicable for what? Boundary surfaces. One is the system, right? One is the system. The other one is what? Surroundings. Second one is surroundings. The third one is boundary surface, right? So these are the terminology. What entire thermodynamics is going to explain, right? So as I said, this is the specified portion which is under my observation, that is called system. The remaining part will be what? Surroundings. The area which divides the system and surroundings is called boundary surface, right? So this is the what? Boundary surface. This is the boundary surface. Then what are the changes? What I said in the importance of thermodynamics. థర్మోడైనమిక్స్ అంటే దేని గురించి? హీట్ చేంజ్ ఎట్లా జరుగుతుంది. ఇప్పుడు దేని గురించి చదువుతున్నాం? సిస్టమ్ తెలుసు, సరౌండింగ్ తెలుసు. సిస్టమ్ సరౌండింగ్స్ మధ్య హీట్ ఎనర్జీ అనేది ఎట్లా ఎక్స్చేంజ్ అవుతుందో దాని గురించి చదువుకుంటాం, రైట్? సో దేర్ ఫోర్ సిస్టమ్ విల్ బి గివ్స్ సమ్ అమౌంట్ ఆఫ్ హీట్ ఎనర్జీ టు ద సరౌండింగ్స్. ఎట్ ద టైమ్ whose temperature will be or heat energy will be more? System heat energy will be more, surroundings will be less, means somehow energy will be transferred to the surroundings, right? Our systems will be, energy will be less, surroundings energy will be more, therefore surroundings to system. So this is the important, two conversions are possible. One will be heat energy is exchange from system to surroundings. The second will be heat energy is exchange from surroundings to system. The entire thermodynamics, with the help of change of these two conversions, we are going to getting all those important concepts and processes of thermodynamics, right? So this is about boundary surface, system, surroundings and boundary surface, right? With the help of this, so we are going to discuss types of systems. How many types of systems are there, right? How many types of systems are there, right? So we are going to discuss about types of systems, so it will be easily understandable, right? So there is types of systems. We have to know all those information with the help of this only. So various processes will be there. First law of thermodynamics, second law of thermodynamics, right? So all those concepts will be involved in that. We have to understand all those things, means definitely we have to understand these basic things. These basic things only can help you to understand the process, because thermodynamics means we have to imagine, right? Imaginary boundary surface will be there. We have to imagine based on our imaginary levels, so how the process will be carried out. From that what we are getting the result that we have to identify, right? Okay, types of systems, right? So that are based on what? Based on boundary surfaces. Based on boundary. What kind of boundary surface is there? Whether it is allowing heat or it is does not allowing heat, whether it is allowing matter or does not allowing matter, right? Based on that heat and matter, right? So boundary surfaces. So we are going to explain the various types of the systems, right? The first system will be open system. First system will be open system. The second one will be, all together we have to discuss, right? Closed system. Closed system. Then the third one will be isolated system. Right, three kinds of systems are there, so that are based on the boundary surfaces, right? One is name itself, open system is there, closed system is there, isolated system. right? So here also we use it to explain boundary surface, then heat will be denoted with Q, and matter will be, whatever is the matter is present in the system, that will be denoted with M. With the help of this boundary surface and heat and matter, we able to get open system, closed system, isolated system. Open system means simple, whatever the system we are going to consider, that becomes open only, right? So whatever is the open system, I can understand with the help of diagram and conditions only, right? So just simple, right? Consider hot water in a beaker. Hot water in a beaker. When hot water in a beaker, right, is kept it on the bench, after few hours, what do you observe? Means the temperature of the water, hot condition, means heat will be transferred to surroundings, right? So whenever it is a open system, right, so heat will be exchanged to the surroundings, and matter also will be exchanged. Both heat and matter will be exchanged with its surroundings. This hot water is a what? This is called a system. So the remaining part will be what? Surroundings. So in between system and surroundings, heat exchange will be carried out. So whenever open system is there, the system in which both heat energy and matter will exchange with its surroundings, such systems are called as open system, right? Initially some Q is there, right? So that means heat of the system, right? So then later on some heat is transferred, that becomes Q1, right? So this Q2 minus Q1, that is the what? Delta Q, right? So Q2 and Q1 both are same? No, Q2 is initial, Q1 is final, so there is a changes will be there, right? If it is a 100 joules heat energy, surroundings will be having 27 joules, that 100 will be converted to up to 27, heat will be exchanged, right? Therefore that will be reduced, means there is a change in heat energy values will be there. So therefore this change will be not equals to 0. So therefore we have to say directly, even matter also, initial matter will be somehow hot water is there. So after evaporation, with the help of open nature, some matter will be exchanged with its surroundings. Therefore matter, initial matter is M2, final matter is M1. This M2 by M1 is not equals 0, means this change is not equals to 0, means there is a change, right? Hence initial and final both not same, right? If initial and final will be same, if you consider initial, final minus initial, that becomes equals to 0, means there is no change. It is not equals 0 means yes, there is a change. Exchange means we are indicating with tick marks, right? Both are exchanged, means what are the conditions we have to remember here? So that are delta Q is not equals to 0, delta M is not equals to 0. Such conditions are applicable for what? Open system. Whatever is the open system is there, energy will be exchanged, heat energy, and as well as matter will be exchanged with surroundings. Simple thing, hot water, right? So most of the people here, right, somehow bring water, right, cold water, so somehow bring cold water in a plastic bottle, right? So when cap will be open, right, so that becomes converted to hot with the help of exchange of heat energy, right? Exchange of heat energy with surroundings. Surroundings are hot condition, so your system will be cold condition. Therefore it will absorb heat energy from the surroundings. That cold water becomes hot. Up to where? To maintain the same temperature inside and outside. Up to there, that temperature, heat energy will be transferred. So when it is open system, means some of the matter will be evaporates, therefore matter also will be changes. These are the conditions. Same thing coming to the part of closed one, right? So this time we are going to consider the hot water, same thing only, hot water, but this time this will be closed one. Whenever it is a closed one, open means matter also will be exchanged. When it is a closed one, right? So here what are those? Here heat will be exchanged with the surroundings, but not matter. Why matter cannot exchange with the surroundings? Means this is the closed system, right? Whenever hot water is there, that water becomes evaporates and touches to the top of the vessel. From there, and it will back as heat will be exchanged. Whenever hot condition is there, somehow evaporation will be takes place. That will be touches to the top. Once the heat energy is decreases, that will be condensed to water. Therefore matter cannot be exchanged, only heat energy can exchange. Therefore, so that conditions will be delta Q will be exchange, means that is not equal 0. There is no change of matter, therefore initial matter and final matter will be same, means the change will be 0. These are the conditions are applicable for what? Closed system, right? So examples also, hot water in a open beaker, right? Examples here, hot water in open beaker, right? Here example will be hot water in a closed beaker or closed vessel. We have to consider closed vessel, right? So coming to the part of isolated system, right? So what is meant by isolated system? With the help of these two systems we are going to get this one easily, right? So here I am going to use, right, such type of systems, right? So here will be, this will be, right, right, this is isolated system, means it cannot allow heat energy to the surroundings. Just now boundary surface we have discussed. What is adiabatic will be there, then diathermic is there. Adiabatic means no exchange of heat, so therefore there is no exchange of heat between system and surroundings. This is the system is a cup of coffee, right, or a cup of tea, which is present in a what? Thermos flask. Now only you are using thermos flask for cold water in summer, right? So once you bring cold water in a thermos flask, so even in entire period, so the same conditions are present in that thermos, means there is no exchange of heat energy, right? So therefore here what we are going to say, Q does not exchange with surroundings, so it is a closed one. Matter also does not exchange with surroundings. With the help of exchange, there is a exchange, means that will be indicated with tick marks. No exchange means that will be indicated with cross marks. Therefore what are the conditions we have to say? This is a thermos flask, a cup of tea is present in a thermos flask, it won't allow heat energy to the surroundings, right? So therefore conditions will be delta Q is equals to 0 and delta M is equals to 0, right? So means both are same, means both are does not exchange with the surroundings. These are the types of the systems. Total 3 systems. Once we have to understand the system, surroundings and boundary surface, with the help of that we will get all this. System means any specified portion which is under our observation. Here what is under my observation? Open beaker containing hot water, this is under my observation. After some time the heat energy will be exchanged, as well as matter also will be evaporates because of open nature. Both will be exchanged with the surroundings, and these are the conditions are applicable, hence it is called open system, right? Coming to the part of this, here also going to discussion about heat and as well as matter. Due to closed vessel, closed nature, matter cannot be exchanged, heat only exchange with the surroundings, right? Such systems are called as closed systems, right? These are the conditions. Then coming to the part of isolated, both heat energy cannot exchange with the surroundings and matter also cannot be exchanged with the surroundings, right? So therefore these are the conditions are applicable for isolated system. So these are the various types of the system. We have to understand the what is the system, what is the surroundings. So then with the help of this various types of the systems are there. So these all the systems will be helpful to understand the concept, various concept, right? So then one more small topic we are going to say, thermodynamic state. Okay, so these are about types of systems, examples, all those things, right? So then we are going to say thermodynamic state, right? Thermodynamic state. What is meant by thermodynamic state and what is meant by thermodynamic process, right? We are going to get the clear idea on that. Thermodynamic state, whatever is the system we may consider, ఏదైనా ఒక సిస్టమ్ తీసుకోండి, ఆ సిస్టమ్ ఎక్కడ ఉంది అంటే ఏం చెప్తారు, పలానా రూమ్లో, right? So what is the temperature of the system? Some room temperature. What is the pressure? Atmospheric pressure. What is the volume of the system? Right, if it is gas, volume, container volume or room volume, right? So if it is liquid and solid, we will get some volumes, right? So means these are these things which will be applicable for the system, right? So what is meant by thermodynamic state means when the system is said to be thermodynamic state, when the system is said to be present in thermodynamic state, this is the system, this is present at what temperature, this is present at what pressure, right? What is the pressure? This is present at what is the volume, right? So temperature, pressure and volume, these will be describes for the system, hence that will be thermodynamic state. And what we are going to see means whatever the properties which are applicable for the system, these properties does not change. These properties does not change with time. As the time is going on, that may not be changed, right? So means that will be explained with the help of simple example, right? I am going to consider one system, right? So that will be system will be denoted with A, then another will be system will be denoted with B, right? So this is the system before the class had started, right? So that means 6:30 p.m., right? 6:30 p.m. This is the system A. At 6:30 p.m. the conditions are what are applicable for this means what are the conditions we have to consider? Temperature, pressure and volume, right? The temperature will be 27 degrees centigrade, pressure will be 1 atmospheric pressure, then volume will be, system of this volume will be for example 1 liter. These are the conditions we have observed at 6:30 p.m. right, after completion of our class, right? So that becomes 8:30 p.m. Is there any changes of these parameters, right? Is there any changes of these parameters, right? So that we'll see, right? Temperature will be same only, right? Right. So temperature will be same temperature, 27 degrees centigrade. Pressure will be, right, 1 atmospheric pressure, then volume will be 1 liter. Is there any changes of these parameters? No, because whatever the system A has, system B also having same parameters. This doesn't change with time, right? So means thermodynamic state means system is considering, how we are considering the system, right? System means any specified portion which is under our observation, right? This is under my observation, this is present at temperature is T, pressure is P, volume is V. These parameters does not change with time. So as the time is progress on, so those all the parameters will be same. Hence, so this system will be present in thermodynamic state. Thermodynamic state. What is meant by thermodynamic process, right? So what is meant by thermodynamic process, right? Here we are going to discuss thermodynamic process, right? Thermodynamics means TD. What is meant by thermodynamic process? Thermodynamic state means does not change with time. These all the properties which are applicable for the system does not change with time. But what is meant by thermodynamic means one of the property can change with time, right? So that means one of the property change with time. Change with time. Hence that is called thermodynamic process. So time gap తీసుకున్నాం, ఇప్పుడు 8:30కి చూసినాం, సేమ్ ఉంది అవే సిస్టము. రేపు నెక్స్ట్ క్లాస్ అవర్లో చూద్దాం, రైట్? సో మీన్స్ ద సేమ్ థింగ్, వాట్ ఎవర్ ద సిస్టమ్ ఏ, దిస్ ఈజ్ ప్రజెంట్ ఎట్ temperature is 27 degrees centigrade, pressure is 1 atm, volume is 1 liter. This is right. So this is at what? Even at our class time, that is PM, right? So that is today. Next day at 6:30, right? So that is system at B, that is next day, right? That means 8:30 p.m. to even 6:30 p.m. This is on next day. Means there is a huge time will be there. In this huge time, temperature will be same only 27 degrees centigrade, right? Pressure will be same only, right? So then volume will be changes 1 liters to 2 liters. How, sir, volume will be possible to increase? As there is a possibility of increasing the volume. If you consider the gases, expansion process will be takes place. During expansion, volume of the gas will be increases. That is possible, right? So volume will be changes here with respect to time. Therefore, hence we may call as this is what? Thermodynamic process. Thermodynamic process. Clearly understand the difference between them. What is meant by thermodynamic state means whatever the fundamental properties which are applicable for the system that may not change with time. సో ఎంతసేపు చూసినా టైం మారినా ప్రాపర్టీస్ సేమ్ ఉంటున్నాయి అంటే దాట్ సిస్టమ్ ఈజ్ ప్రజెంట్ ఇన్ థర్మోడైనమిక్ స్టేట్. అట్లా కాకుండా ఏమవుతున్నాయి, టైంతో పాటు మారుతున్నాయి. ఫర్ ఎగ్జాంపుల్ స్నవ్ క్లాస్లో 100 మెంబర్స్ ఉన్నారు, రైట్? క్లాస్ స్టార్ట్ అయినప్పుడు 100 మెంబర్స్ ఉన్నారు. క్లాస్ ఎండింగ్లో మధ్యలో ఇద్దరు ఎగిరిపోయారు, రైట్? సో మీన్స్ నంబర్ విల్ బి చేంజ్ ఆర్ నాట్? యాజ్ దెర్ ఇస్ ఎ చేంజ్ మీన్స్ ఇన్వాల్వ్డ్ ఇన్ థర్మోడైనమిక్ ప్రాసెస్. క్లాస్ అయిపోదాకా 100 మందికి 100 మంది యాజ్ ఇట్ ఈజ్ ఉన్నారు అనుకో, అప్పుడు ఏమంటాం? థర్మోడైనమిక్ స్టేట్ అంటాం, రైట్? సో దట్ ఈస్ ఎగ్జాంపుల్. సో వెన్ దీస్ ప్రాపర్టీస్ డస్ నాట్ చేంజ్ విత్ టైమ్, thermodynamic state, the properties will be changed with time. One of the property, not all, any one of the property that will be changed with time. Therefore, hence that is involved in thermodynamic process, right? There is a various thermodynamic processes are there, right? So what are the thermodynamic properties? Process. Before that, we are going to discuss about thermodynamic state. So this state will be consisting what? Thermodynamic properties, right? So what are the thermodynamic properties we are going to discuss with the help of the thermodynamic properties, right? So we will get some more information, right? Thermodynamic properties. Right. These properties that will be depends on, right, based on amount of substance, right? So what we are going to say, based on amount of substance or weight of substance or based on number of moles, based on number of moles. What are the thermodynamic properties? That properties we are going to identify based on the what? Weight of the substance. Any property you may consider that will be depends on weight of the substance or independent on weight of the substance. Based on that, so we can get two types of thermodynamic properties, right? So that one will be extensive property. The other one will be intensive property. Right. So there is a possible to get one question from this concept, right? So definitely, so because nature of extensive and intensive, right? So extensive property, intensive property. These two properties are based on what? Weight of the substance or number of moles, right? So any property which is depends on the weight of the substance, right? So just here I am going to write any property which will be depends on weight of substance that will be present in the system, right? Depends on weight of the substance present in the system. That is called what? Extensive property, right? In intensive I will be there. Therefore here independent on weight of substance, right? So like that, as we know the nature of the property or definition of the property, therefore we can segregate that is either intensive or extensive, right? So I am going to give one property, right? I am going to give one property, that is pressure. One atmospheric pressure, that is depends on any weight. 1 atm pressure antunna, atmospheric pressure, that is emana baruvu untada, atmospheric pressure. సో దట్ ఈస్ ఇండిపెండెంట్ ఆన్ వెయిట్ ఆఫ్ ది సబ్స్టాన్స్. అంటే ఎలాంటి వెయిట్ మీద డిపెండ్ కాదు, ఎలాంటి నెంబర్ ఆఫ్ మోల్స్ మీద డిపెండ్ కాదు. అంటే ప్రెషర్ అనేది ఏ ప్రాపర్టీ అవుతుంది? ఇంటెన్సివ్. ఇండిపెండెంట్ ఆన్ వెయిట్ ఆఫ్ ది సబ్స్టాన్స్, దెర్ఫోర్ ఇంటెన్సివ్. రైట్. ఏదైనా వాల్యూమ్ తీసుకో. రైట్. సో మీ వాటర్ బాటిల్సే ఉన్నాయి, 1 లీటర్ బాటిల్ ఈజ్ దేర్. 1 లీటర్ అనేది వెయిట్ మీద డిపెండ్ అవుతుందా? ఇంటి నుంచి మోసుకొస్తున్నావు, ఏమైనా వెయిట్ ఉందా? లేకపోతే జస్ట్ గాలిలో పట్టుకొని వస్తున్నావా వితౌట్ వెయిట్? సెస్ 1 liter means volume is depends on weight of the substance, therefore so hence that is what volume is what extensive property. Volume is extensive property. Right. Temperature, now we are at room temperature and even somehow outside temperature will be more, around 40 will be there in summer. Right. 40 degrees centigrade means it is depends on any weight? No, therefore temperature is intensive property. Independent on weight of the substance, all are come under intensive. Dependent on weight of the substance are come under extensive. Right. So mass will be extensive property. Mass will be extensive. Whenever volume is extensive, right, so therefore length also extensive, then area also extensive, then force also extensive, right. So then here coming to here, viscosity, right. Viscosity is what? Intensive property. It is not depends on viscosity, right. It is not depends on weight of the substance. Next, surface tension. Surface tension is intensive property. Refractive index, right. So that is with respect to the velocity in vacuum by velocity in medium, so that is called refractive index. So both velocities will be there, so that will be independent on weight, hence that is refractive index, that is intensive property. Now I am going to give concentration, or else first number of moles I will consider. Number of moles. What is the definition of number of moles? Weight by molecular weight. Weight by molecular weight, that is called number of moles. Number of moles will be intensive property or extensive property, right. So that will explain with the help of easily, right. So 1 mole of water consisting how many grams? 18 grams of water. 1 mole means weight by molecular weight. What is the molecular weight of water? 18. 18 by 18 means that is 1 mole we are getting, right. 1 mole of water means what? 18 grams of water. 18 grams of water. 1 mole రావాలంటే ఏం చేయాలి? weight by molecular weight. Molecular weight of water is 18 only. 18 by 18 చేస్తే 1 వస్తుంది. Therefore 1 mole is consisting how many grams? 18 grams. If you may consider 2 moles of water, right. How many grams? 1 mole ki 18 grams అయితే 2 moles ki 2 into 18, that is 36 grams. Is it dependent on weight or not? Yes, this is depends on weight. Therefore hence number of moles is which property? Extensive property. Number of moles is extensive property. Number of moles depends on weight of the substance, right. 1 mole is 18 grams, 2 moles is 36 grams. Therefore number of moles is depends on weight only. Therefore hence it is a extensive property, right. So then consider concentration, right. So concentration, what is meant by concentration definition? Right. As you know the definition, therefore you can segregate whether it is intensive or extensive easily. Concentration, the concentration C will be N by V, right. N is number of moles. Number of moles is the what? Extensive property. Right. Volume also extensive property, right. Here volume is extensive property, number of moles extensive property. So therefore hence the ratio of extensive properties by extensive properties, that becomes intensive property. So I will give example for this. The ratio will be intensive means hence concentration will be what? Intensive. Concentration is intensive, right. Concentration is intensive property, right. That is independent on weight of the substance present in the system. Like that we will go with the definitions. We can get segregation of intensive and extensive properties, right. So somehow I am giving the list that will be come under extensive properties and some other will be come under intensive properties, right. Here number of moles will be there, right. Next, entropy, right? Enthalpy, Gibbs free energy, then Helmholtz energy function, then all this entropy. These all are thermodynamic properties, right? So this is the internal energy, this is the entropy, this is the Gibbs free energy, right? So this is the enthalpy, this is the Helmholtz energy function, These all are extensive properties which are depends on number of moles and weight of the substance present in the system. You have to remember whatever is the property will be given, whether that is depends or independent on the system that we are going to identify. It is dependent, extensive property. It is independent, intensive property, right? So coming to the part of density. Density is which property? Density, intensive property, because density is equals to, what is the formula? Mass by volume. Mass is extensive property, volume also extensive property. The ratio of extensive property becomes intensive property. Therefore density also intensive property. The ratio of intensive properties becomes also intensive only, right? Any two intensive properties we have to consider. P by T we have to consider. Both are intensive. The obtained also intensive only. So when two extensive properties are there, that ratio becomes intensive only, right? So with the help of this, we are going to get some more intensive properties, right? So that we will write. So that some more intensive properties, how we have to express means intensive we are writing, right? So this is the very important. It will be easy to identify whether it is intensive or extensive, right? So our important note also, right, you have to write. Any property is expressed. Any property is expressed in terms of, that property will be expressed in terms of per unit area, right, or per unit mole. This is also we may called as per mole also, per mole, or per gram, or per volume, right? Means all we are expressed per means particular. Unit area means area will be 1, unit area. Unit mole means mole will be 1. Unit gram means per gram. Unit volume means per volume. These all are expressed per 1 only. Means unit area means 1. Per mole means 1 mole, per gram means 1 gram, per volume means 1 volume. So all these properties are becomes what? Intensive properties. Any property we are going to express in terms of that is come under intensive property. Example I am going to here write. Specific heat capacity. Specific word is there. Means that becomes any one of it will come, either per unit mole, per mole, or per gram, or per volume, anything will become. So therefore this specific heat capacity will be intensive property, right? Next, molar heat capacity also intensive, right? Next, molar, right, whatever here internal energy will be there, enthalpy is there, entropy is there, therefore molar entropy, that becomes intensive. Entropy is the extensive property, depends on weight, but specific or molar entropy becomes intensive property. Any property will be expressed per this, like in terms of that becomes intensive property. So remember thing, entropy is extensive, molar entropy is intensive. Enthalpy is extensive, right? Enthalpy is extensive, then molar enthalpy is intensive. Molar means per mole we are getting enthalpy, right? So next, molar Gibbs free energy. Next, molar Helmholtz energy function. Whatever is the property will be expressed in terms of specific kind. that all will be come under intensive properties only. So like that we have to remember that, right? Intensive means independent, we have to remember. Weight మీద డిపెండ్ కావద్దు. ఈ ప్రాపర్టీస్ ఏవి తీసుకున్నా weight మీద డిపెండ్ కావు. Weight means amount of substance that is present in the system. So such properties are intensive properties. ఏవైతే weight మీద డిపెండ్ అవుతాయో అవన్నీ ఎక్స్టెన్సివ్ ప్రాపర్టీస్, రైట్? ఎక్స్టెన్సివ్లో ఏమేమి వస్తాయి? మాస్, వాల్యూమ్, length, area, force and thermodynamic properties, heat capacities, all those come under extensive. Whenever those properties will be expressed per unit area, per unit volume, per unit grams, right? So per unit volume, all those things that will be come under intensive properties. And here the ratio of extensive properties by extensive property becomes intensive property, and also the ratio of intensive property by intensive property, that is also called intensive property only. Intensive property only, right? So these are about somehow introduction topics, right? Like what we have discussed today. One will be importance of the thermodynamics, then what are the limitations, what we are going to discuss entire thermodynamics. Then after that, so what is the terminology involved in that? Systems, surroundings and boundary surface. How many type of boundary surfaces will be there? Based on that boundary surface, what are the types of the systems? Open system, closed system and isolated system, right? Then after that, thermodynamic state, thermodynamic process, then thermodynamic properties, right? So these are intensive and extensive properties. Some other state functions and path functions are there after that. So whenever we are going to discuss about one form of energy is converted to other form of energy, heat is converted to other form of energy. So what are the conversions will be there? What are the other form of energies? What are the definitions? All those things that will be covered in the next class. Okay, right? So definitely we'll discuss some numericals based on this intensive and extensive property, and the next state functions and path functions and all those basics concepts we will discuss numericals in the next class, right? Until then, bye.